Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
This question is actually testing your understanding on nerve impulse transmission, which is from topic 15, coordination. So the question is actually referring to anaerobic respiration producing not enough ATP. So now we're saying that because of this, when there's no ATP, sodium-potassium pump stops working. So the question here is, do you know where sodium-potassium pump is working? So along the neuron, you need to know that when your membrane is at resting state, your membrane potential is always maintained at negative 70 millivolt. So it means that you have more positive charge ion outside and inside will be less positive, resulting in a difference of negative 70 millivolt. So now, when sodium-potassium pump stops working, what happens? The membrane starts to depolarize. So depolarizes basically means your membrane potential starts to become more positive. So let's look at what is the expectation of the question. So the question is asking why the membrane will actually depolarizes when sodium-potassium pump stops working. So you need to understand that depolarizes means inside becomes more positive. So now we need to understand that what is the role of sodium-potassium pump. So in a resting neuron, we know that inside is more negative and outside is more positive. And this is possible because sodium-potassium pump is actively pumping out 3 Na plus and 2 K plus is coming in. So this is an imbalance of charge, therefore resulting in negative 70 millivolt of membrane potential. So if there is no ATP and this sodium-potassium pump stops working, what happens here is the Na plus, instead of being actively pumped out, the sodium channel will start to open and sodium ion will diffuse down the gradient. As we previously know that Na plus would have high concentration outside as it is being pumped against the concentration gradient. Therefore, you would have built up a high concentration of Na plus outside the axon. So now Na plus will diffuse down the gradient into the axon, which is also known as influx of Na plus. Therefore, inside will becomes more positive. So instead of negative 70 millivolt, it most likely is going to become more positive, which is more than negative 70, which it might go up to positive 30 millivolt. So now, what are the expected marking points? So number one, we will say that when there is no ATP, sodium-potassium pump stops working. Therefore, resting potential is not maintained. Then, resulting in the negative charge within the axon, or we call it the neuron, is not maintained. So if you're not maintaining a negative charge, but how does it become positive then? The Na plus will diffuse down the concentration gradient into the axon. So inside the neuron now becomes less negative. So this is how you need the understanding about resting potential and the understanding about what it meant by depolarization.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.